So think about it as an open but end-to-end AI workflow concept, so that you can, again, start with your model, you can tune it, you can optimize it, deploy it, profile, the whole end-to-end workflow. Just like the rest of CodeFusion supports the entire workflow, we're now doing that, or providing that for AI.
In this episode of Embedded Insiders, the VP of Sales and Business Development at GateWorks Corporation, Kelly Peralta, joins me to discuss the trends, challenges, and innovations surrounding Wi-Fi HaLow for industrial and IoT applications. The next segment is sponsored by Analog Devices, and contributing editor Rich Nass and Analog Devices Senior Vice President of Software and Digital Platforms, Rob Oshana, discuss the complexity of designing AI systems and how Analog Devices' CodeFusion Studio, which includes an IDE, a software development kit, and coding tools, is designed to accelerate the process. But first, be sure to check out the description of this podcast to view the Embedded World North America 2025 Best in Show winners. Hello, everyone, and welcome back to the Embedded Insiders podcast. I am Assistant Managing Editor Tiara Oliver. Since Embedded World North America is taking place this week in Anaheim, California, I'm here to give you a brief introduction into this week's podcast, while Ken is away at the event, but is sure to be back soon to give us all the details. As always, Embedded Computing Design has chosen its Best in Show winners for Embedded World North America 2025. So be sure to click the link in the description of this podcast to see what products and what companies were chosen. To keep it brief for this week's intro, be sure to stay tuned as we've got some great interviews coming up. We've got a sponsored segment from Analog Devices and a discussion about the benefits of Wi-Fi HaLow with GateWorks Corporation. Now, here's Kelly Peralta, VP of Sales and Business Development at GateWorks Corporation. Kelly, before we get started into some of the questions, do you mind giving us some of your background and your role at GateWorks?
Sure, happy to. So I'm Kelly Peralta. I'm the VP of Sales and Business Development for GateWorks Corporation in San Luis Obispo, California. And I've been here for about 6 years. I am in charge of the strategy for wireless and for market strategy, as well as key customer engagements and growth for the company. So one of the strategies that I had early on at GateWorks was to engage in the Wi-Fi HaLow market. I've been in the wireless business for a really long time and saw that emerging technology as a great fit for our industrial customers.
So for those who may not know, what is Wi-Fi HaLow and how does it differ from more traditional Wi-Fi technologies?
So Wi-Fi HaLow is Wi-Fi. It's a Wi-Fi standard. It's 802.11ah. And it differs from standard Wi-Fi because it is lower power and lower throughput, but extended range. For example, it is currently we're working on a module, a Wi-Fi HaLow module that can do 42 megabits per second. And traditional Wi-Fi, of course, is much higher throughput. HaLow operates in the sub-gigahertz range. So the key differentiator is that it allows communications of IoT data to go significant distances. For example, video can be sent over miles.
So what are some of the most common use cases or applications that you're seeing, Wi-Fi HaLow being more optimized for?
Well, there's a lot, but at GateWorks, we're very focused on industrial IoT. So our use cases are in the smart factory, smart energy, and smart transportation markets. The smart factory killer app that I'm following quite closely is AMRs, autonomous mobile robots. And ABI research says that AMR shipments will grow to 2.79 million units by 2030 and generate 170 billion. So I've been following this trend, and we are currently working on an AMR application where HaLow is solving connectivity issues in the factory. Things like better accuracy, better latency, much lower infrastructure cost, and much better battery life than traditional Wi-Fi. Now, the other market that we're following very closely is the energy market. And the things that are driving HaLow in this market are Smart Grid 2.0 and Energy 4.0, where smart meters, for example, are adopting AI to solve additional use cases for connecting meters and monitoring energy and monitoring the smart grid. So with AI, more bandwidth is required. So things like LoRaWAN don't operate very well in this kind of use case. And cellular is expensive. So traditional Wi-Fi won't go the distance. So traditional Wi-Fi is limited on range, and HaLow is going to solve that problem, I believe, for Smart Energy 2.0.
And you just mentioned LoRaWAN and cellular. Are there any other, advantages that Wi-Fi HaLow provides over LoRaWAN or Zigbee or any other cellular IoT connectivity solutions?
Yes, so HaLow competes with LoRaWAN quite often, specifically in the agriculture market. LoRaWAN technology is not a Wi-Fi standard, so it doesn't have the same interoperability capabilities that HaLow does. LoRaWAN will go further, but it doesn't have the same ability to use any sort of significant IoT throughput to send packets. So HaLow has higher throughput. LoRaWAN goes a little bit further. Cellular doesn't operate everywhere, so sometimes I'm seeing HaLow take over for cellular in some use cases where there's no coverage and they need to do a backhaul of some sort, and they can aggregate a lot of different nodes and collect them all into a backhaul and communicate that way. Zigbee, I'm not hearing too much about Zigbee lately because I think it was plagued by interoperability issues. And so I really think that HaLow is going to be taking some of the market share from cellular IoT and LoRaWAN.
And you mentioned industrial IoT as the main focus for GateWorks as far as Wi-Fi HaLow. Can you expand on some of the work that you guys are doing in industrial IoT and maybe some of the goals that you're focusing on specifically right now in the industry?
Well, for HaLow, the key market segments that we are specifically focused on right now are retail, which is a little bit consumer, but there's a big shift in retail right now for HaLow, and smart energy. So those are the big ones, and those are the ones that the chip makers are going after as well. So in retail, for example, you can put up to 8,000 devices per AP with HaLow. And this type of communication capability is going to find its way into things like electronic shelf labels and other retail applications such as security or asset tracking. Take a retail establishment, for example, where there's a lot of metal housings, there's a lot of metal racks, there's a lot of product. And in stores and warehouses, HaLow's operating in the sub-gigahertz frequency, right? So that band allows its signals to travel much further and penetrate obstacles like walls and shelving, et cetera. And it's still going to do that with the same security as Wi-Fi, WPA3, for example. And it's going to allow significantly lower infrastructure cost with the ability to put so many nodes on one AP, up to 8,000.
Awesome. And then just out of curiosity, are there any other industries maybe looking forward to the future or even maybe the more recent future, but are there any other industries that maybe you expect to see this adopt, or that you expect to adopt Wi-Fi HaLow, but they just
Uh,
haven't yet?
yeah, besides retail and smart energy, which I think are the two big ones that are going to go pretty quickly.
Mhm.
But over the next 3 to 5 years, you're going to see industrial IoT and all of the applications that I mentioned for example, in factory automation and in robotics, evolve into use cases where slightly lower throughput, but much longer range, and being able to communicate with a lot of different devices is going to be a big advantage. So those are the main ones, and I think HaLow is really suited to take a big leap in the very near future.
And then looking outside of industry, where do you see Wi-Fi HaLow moving in the next couple years, maybe within your company, maybe your goals, or kind of what you guys are looking forward to doing with this technology?
Sure. So, we got into the HaLow market as a wireless solution provider. We are currently teaming with Morse Micro, and we're about to develop our third HaLow product. And we develop a module and an embedded board. So you're going to find GateWorks more in edge computing and gateways and things like that, where you'll find the chips in the meters or in the shelf labels. But I can tell you that today, we have over 2,000 new customers using Wi-Fi HaLow. Probably more than 50% of the customers that are contacting us, new leads, new opportunities, are trying to incorporate HaLow. And so, I mean, I feel that we're well positioned, and I think that there are several very large customers that are about to jump into this market. And when they do, I think that the industry is going to follow. In addition, you're seeing module vendors jump in as well, people like Azure Wave, Murata, and Quectel. So I really think it's going to explode. And we're not the super high volume solution provider, but we're the connectivity provider and the gateway provider. So we're looking forward to a lot of high growth. So I think we covered it pretty well. We're excited about HaLow, and Morse Micro is our partner. And I think in the next year, you're going to see a lot of big differences in the market.
Awesome. We're looking forward to it.
Now, here's Rob Oshana, Senior Vice President of Software and Digital Platforms at Analog Devices.
Good afternoon. My name is Rich Ness. I am with Embedded Computing Design. I'm here with Rob Oshana, the Senior Vice President of Software and Digital Platforms for Analog Devices. How you doing, Rob?
I'm doing good, Rich. How are you doing?
Just fine. Thank you very much. So, timely podcast, because you guys just made an announcement that I want to dive into, but for a particular reason. I mean, it's a great product on its own, but what makes this stand out for me, at least, is how you've sort of integrated everything into one cohesive package. A lot of the AI announcements that I see might be from a chip vendor, and they say we have the best piece of silicon out there, and in a lot of cases it's actually true. However, you have to go somewhere else if you want the tools. You have to go to a third guy if you want to integrate an operating system, and the hooks aren't in there, and it's just not easy. And AI on its own is hard enough, so why make it even harder for an engineer? So I want you to explain to me what you guys have done and how you've been able to do that. And then if you can remember all these questions, what does that mean for the engineer? How does he roll that out into his design?
Yeah, no, Rich, that's a great question. And you're right. We don't want our customers to have detailed knowledge of AI, ML, or a PhD, or even be able to navigate all these different technologies and tools. So from the very beginning, when we started building our platform, CodeFusion, we kept that in mind, and we built it not only to be open, so we can build a community around it and others can contribute and participate in that community, but from the very beginning, we looked at user experience and designed that in from the very beginning, because we knew that at the end of the day, with these these complex heterogeneous processors that include an AI accelerator, as well as, DSPs and cores and everything else. We've got to make the user experience easy so that our customers can get productive and time to market. And the way to do that is with the right levels of abstraction built into our tools. And we provided that. And we provided that at the driver level, at the OS level, and even at the HAL and application level. So our customers can come in at different levels of abstraction depending on where they want to operate from. And that's I think what we achieved with CodeFusion.
Okay, can you clarify that? What do you mean by coming in at different layers of abstraction? What does that mean?
Yeah, that means some of our customers may want to build their application right on top of a driver, no OS. So OS kind of bare metal applications. Others want to come in at the OS level, like Zephyr or Linux, and they want to build their application on top of an operating system. So these are what I mean by different levels of abstraction. Even above the operating system, you may want to, or we do provide a common HAL, hardware abstraction layer, where the customers can operate in even a more abstract layer on top of libraries and other useful software. So that's what I mean by they can operate at different levels of detail or abstraction.
Okay. And what's the new part about this? You guys just announced this week, as a matter of fact. What is this announcement? Because CodeFusion itself is not new.
Right. CodeFusion's been out there and it's been doing very well. And just as a reminder, 3 major components: an IDE, a software development kit, and a bunch of config tools. And it was designed to be extendable, not just through VS Code, but other forms of extension and scalability. So what we added this time is additional add-ons, if you will, additional scalability to support AI. So we built in the capability of our customers to be able to bring, for example, their data or their model and integrate it and literally deploy it onto a piece of silicon through our tools very easily. So think about it as an open but end-to-end AI workflow concept, so that you can, again, start with your model, you can tune it, you can optimize it, deploy it, profile, the whole end-to-end workflow. Just like the rest of CodeFusion supports the entire workflow, we're now doing that, we're providing that for AI.
Okay. Are there particular applications that this is most suited for?
Yeah, we built this to support our main vertical applications, so primarily automotive, industrial, healthcare, data center, and just consumer, and even aerospace and defense. So it supports those in a pretty seamless way. The workflow is pretty consistent across those applications.
Okay. Analog Devices is a pretty big company, and you guys do lots of different things. Are there hooks built in to build out a complete system beyond the MCU and some of the peripheral stuff?
Yeah, that's a great question. Actually, because we have very differentiated signal chains, our analog portfolio, we've got thousands of these signal chains. We wanted to make it easy for customers to take either one of our MCUs or other MCUs and integrate that easily and seamlessly into one of our analog signal chains. And so CodeFusion provides that capability of being able to do that, selecting a signal chain and quote unquote attaching it to an MCU of choice. Doesn't have to be ours, but we make that easy either way by providing frameworks for driver creation and OS integration. Rich, one of the things, like when we first launched CodeFusion, we chose, at least from an RTOS perspective, Zephyr is our supported RTOS. We'll support others, but Zephyr was our default. So if you want to use something in the Zephyr community, we can easily interrogate that MCU and auto-generate the drivers based on the peripherals in the device tree of that Zephyr MCU, all through open source. So it's actually pretty easy to provide our customer whatever they want, whatever combination of analog and digital in our environment through CodeFusion.
Does Zephyr lend itself to a particular application?
Well, yeah, a lot of it is for these. It's getting better. It started off in mostly consumer, but now we're seeing Zephyr in automotive, industrial, and even aerospace and defense. So it's becoming. It's not just a kernel like FreeRTOS. It's a whole environment now, Rich. So it now supports many other different types of applications.
So going back to what we started with this platform approach where you have the integration of the various tools. I know it's not easy to do, but why aren't other people using the same approach?
Well, I think, we came at this from the perspective of making everything open in order to build a community around us. Others have a little bit more of a walled garden. We just decided we wanted to take an open approach. It was a risk at the time, but I think it's paid off. I think the second thing that motivated us to kind of take a slightly different direction is with our signal chains, we can produce very interesting data. And we combine that with AI, we call this physical intelligence. It's essentially being able to integrate AI with the physical world. And what I mean by that is the electrophysical domain, where we're really good with our signal chains. So we took a kind of an AI analog physical intelligence perspective, at least in this new release of CodeFusion, that I think is ahead of some of our competition in thinking this way. And then we made it open on top of it. So much more of a integration of analog than I think others have been doing to this point. So we just thought ahead from the beginning on this one.
Very good. So in my head, I was going to ask you, what's the starting point for somebody? And you'd probably say, go to analog.com. But what are the prerequisites? What do you need to know to get started in what's a fairly complex AI world?
Yeah, definitely. I think we wanted to make it easy to find and deploy not just a model. Like, so you hear about customers want to build these AI models. Okay, that's fine. And we provide that, and we provide a little hugging tree capability so the customer can find that model, do what's called graph lowering, deploy that model to our silicon. But in addition to that, that can be difficult, Rich. So what we do is we provide all the reference code to be able to plumb an application to ingress data, do the inferencing, egress data, and all that sample code. We provide all that in optimized libraries so that customers don't have to do that themselves. And so it makes it a lot easier to deploy a full application based on AI instead of like bits and pieces that can happen if you're not taking a system view.
So is now the right time to jump in? I mean, will it get easier down the road, or?
Yeah, when I tell people, and I've been through the DSP era too, and you saw that start off very complex. You needed to be an expert at signal processing, and you saw over the years via tools and other forms of abstraction and code and everything else, DSP got easier and easier. I think with this, it's kind of sort of the same. I think you're going to see more and more tools getting deployed, more code and libraries and other capability that will make AI and ML easier. And I think it's not exactly apples to apples, but it will continue to get easier over time. I think it has to if we're going to deploy this technology at scale in the industry.
Awesome. Thanks, Rob. I appreciate taking the time to explain this. This is cool stuff.
Always great talking to you, Rich.
That was Rob Oshana, the Senior Vice President of Software and Digital Platforms with Analog Devices, and I'm Rich Nass with Embedded Computing Design.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.